Good afternoon, everybody. Thank you for the chance for me to present our research result. So today I would like to present our research entitled Isolation, Thermotolerant and Ethanol-Tolerant Yeast from Local Vegetables and Their Potential as Bioethanol Producers. So this is our team. My name is Muhammad Nurkolis, and also my teams, Ricky Kurniawan, Johnny Kusnadi, and Jaya Mahar Malikan. We all belong to Department of Agricultural Product Technology, Universitas Brawijaya, Indonesia. This is the outline for my presentation: introduction, methods, result and discussion, and conclusions. First of all, I would like to introduce our background. As you know, as a global challenge of a worldwide, and we know rising the human population has an impact for increasing crude oil consumption. And then this also influences the limited fossil resources. As we know, the production of fuel production and energy in Indonesia, we can see in this chart, only 2% of biofuel production. This is a very small amount compared to crude oil or coal or natural gas. So, and another background is biofuel demand is increasing by regions 2010 up to 2050. Not only in Asia, but also in America and Europe, this biofuel demand is increasing. So the interest for bioethanol or biofuel is as a renewable energy source is very increased. And also, maybe some of you already know about thermotolerant microorganisms. This is a microorganism that has a tolerance to high temperature. So it's different with thermophilic microorganism. This is coming from the mesophil microbes that has a tolerance to higher temperature. And why we need to explore the thermotolerant microbes, because in our worldwide right now, we're facing about global temperatures, and that's increasing temperature with correspond to production of fermentation, something like that. And the ethanol fermentation process is exothermic, so need cooling system. If we have a good thermotolerant microbes, we can apply this microbe to high temperature fermentation because it can decrease risk of contaminations, because most of a contaminant can grow around 37 or below 37. So if we have a high thermotolerant microbes, we can reduce also cooling and operating costs, and we can apply for efficient simultaneous saccharification and fermentation. And our methods, we focus on yeast isolation from 10 vegetables. Previously, we already isolate from local fruits, but today I would like to emphasize in vegetables. We isolate from 10 vegetables, such as white broccoli, potatoes, yellow cabbage, leeks, mustard greens, bitter melon, kale, celery, carrots, and green broccoli on YB glucose agar at 37, 40, and 45 degrees Celsius. The next step, we test at various temperature, 30, 37, 40, 42, 45, 50, 55, and 60 degrees Celsius. And then we continue with the ethanol tolerant test at 4.5%, 6, 7, 8, 9, 10, 12, 15, 18, and 20%. After we obtain the good isolate at high temperature and at high ethanol concentration, then we will test for bioethanol production in liquid YP plus 10% glucose at 40 degrees Celsius for the first trial. Then we select a potential yeast isolate. We expect we got the rapid growth rate yeast and generally recognized as safe, and for sure we would utilize various sugar yeast and can produce ethanol in high concentration and also thermotolerant. And this is the result and discussion for our research. We obtained 11 yeast isolate from 10 vegetables, and only 1, 2, 3, 4, 5 vegetables that we can obtain the yeast isolate. Another is bacteria isolates. Only squash, green beans, carrot, kale, and celery. Later we name this isolate. Then we check at high temperature, and most of them can grow at 37, 40, and 45. But all of them cannot grow at 50, 55, and 60 degrees Celsius. And this is the plus means more plus mean isolates grow very well, and minus means isolate cannot grow. And then at ethanol concentration, most of them can tolerate up to 10%, and some of them can tolerate until 15%. Only isolate S17E cannot grow at ethanol concentration 15%. Then we check ethanol production tests. Some of them cannot produce ethanol at high temperature. But if we see S17D can produce the highest ethanol, around 3.2% at 24 hours. And S17E, both derive from kale vegetables, so it can produce ethanol from 12 hours. Those interesting data can be used for the further experiment. And the conclusion of our research is all yeast isolates were tolerant to the temperature of 45 degrees Celsius, and only one isolate S17E derived from kale was unable to grow at ethanol concentration of 15%. Isolate S17D derived from kale was potential isolate because able to grow at high temperature and high ethanol concentration. The isolate also could produce ethanol as much as 3.1% at 24 hours. Thank you for your attention. That's all my presentation.